First question, student investigate the period or time period of oscillation of a simple pendulum. Different labels are there. The student measure the distance between the bottom of the clamp and the floor. So student measure this distance D, this total distance, which was 120 centimeter. This distance remained constant throughout the experiment. This distance D remained constant throughout the experiment. He adjusted the length of a pendulum to be 70 centimeter. So here he adjusted, like this total was 120. D was equals to 120 centimeters, and he adjusted the length of a pendulum to be 70 centimeter. So it means X will be how much? It will be 120 minus 70, which is 50. Calculate the distance X between the center of the pendulum bob and the floor and record the value of X in first row of table 1.1. So first row of table 1.1. So what will be the answer here? That will be equal to 50. In part B, student displaces the bob of a pendulum and release. Figure 1.2 shows one complete oscillation of a pendulum. He measure and record in first two rows of table 1.1 the time for 10 complete oscillations. Calculate and record in the first row of a table 1.1 the period, the time period, and for one oscillation, and then calculate and record in the first row of a table 1.1 t square and complete the column heading. What is the meaning of a column heading? The term column heading means units. So we have to complete table 1.1. So how we'll complete this table 1.1? This value is already recorded, that was 50. Now complete the column heading. Column heading means unit. So what will the unit of a distance? As we did 120 centimeter minus 70 centimeter, which was 50 centimeter. So what is the unit of the X? The unit of X is in centimeter. Then unit of time, this is the time for 20 oscillation or 10 vibration, that was in seconds. And then time period also will get in second. And t square, when time period square, so that will be equal to second square. So if the time for 10 oscillation, this is the time for 10 vibration or 10 oscillations, that is 16.7. What will be the time period of oscillation or time to complete one vibration? Use a screen annotation to complete this missing value. What will be the time for one oscillation? If 10 oscillations took 16.7 seconds, how much time it will take for one oscillation? .67, not because we are dividing by 10. It is time for 10 oscillation is 16.7. So if it is 16.7 for 10, we need for 1, so we divide it by 10, so it will be 1.67. So this will be 1.67. And t square. T square means time period square. So what is time period square? Means we just 1.67 square. So we are all the answers are in three significant figures. So 1.67 square, that will come out as 2.78 or 2.79. This is 2.79 second square. So when they ask for column heading, it means you have to complete the units. The next part, we have to plot a graph for t square on y-axis and x on x-axis. So first, I will write the value so that I can use those values to plot a graph. We have x and t square. When x is equals to 50, t square is 2.79. When x is equals to 45, t square is 2.99. When x is equals to 40, t square is 3.20. When x is equals to 35, t square is 3.39. And when x is equals to 30, t square is equals to 3.61. So now we'll use these values to plot a graph between t square and x. And they mention plot t square on y-axis and x is on t square on y-axis and x is on x-axis. And you do not need to start your axis at origin. Means we don't have to include origin, like we don't have to mention 0, 0. We can start with any number. So if I can start with any number, and they mention x-axis, I should have x. So we'll draw a line. And this one is x we are plotting. And what is the unit? That is in centimeter. It is important that you write the units correctly for the axis. And on y-axis, we are plotting t square. So we have t square on y-axis, and what is the unit? Second square. Now for x-axis, our maximum value is 50 and the minimum is 30. So if I start my axis with 30, say this is 30, then after 20 boxes it is 40, and then after 20 boxes it is 50. So in between them there will be 35. In between them there will be 45 and then 55. So as I mentioned, we don't have to include origin, so we don't have to start our axis with 0. We can start with any number. Try to expand your scale so that you can use 70% of your graph paper. When you check for t square, the minimum value is 2.79 and the maximum value is 3.6. So I will start, example, if I start with 2.5, then we can check with, so if I start with say 2.5, then 2.6, 2.7, 2.8, 2.9 and 3. So this is not correct. Why this is not correct? Because I'm not able to get to 3.6. So that's why I cannot use this scale. And my minimum value is 2. So even if I start with example 2.7, so I start with 2.7, then I start with 2.8, 2.9, 3.0, 3.1, 3.2. So again, I'm not getting to 3.6. So I mean, this is not correct scale. So if I divide, like example, 10 boxes is equals to 0.2. So 2.7, 2.9, 3.1, 3.3, 3.5 and 3.7. So here you can see now I have 3.7. So it means I can plot 3.6 on my scale. So in between them, like because 10 boxes equal to 0.2, so 5 boxes equals to 0.1. So between them 1, 2, 3, 4 and 5, there will be 2.8. Then again 1, 2, 3, 4, 5, there will be 3.0. Then 1, 2, 3, 4, 5, there will be 3.2. Then after 5 boxes, there will be 3.4 and then 3.6 will be there. So this is the correct y-axis labels and the x-axis. Now we plot, like mark the points. So when x is equals to 50, t square is 2.79. So 50 and 2.79, because each box is equals to 0.2, like this is 2.72, 2.74, 2.76, 2.78. So between 2.78 and 2.80, there will be 2.79. So this point will be between 2.8 and 2.78. That's the first point. The second point, when it is 45 and 2.99. So 45 and 2.99. So 2.99 is approximately closer to 3. Then it is 40 and 3.2. So 40 and 3.2. 35 and 3.39. So 35 and 3.39. This is 3.32, 3.34, 3.36, 3.38, and 3.39. And then 30 and 3.6. So 30 and 3.6 is here. Now what we do, use thin lines whenever you join the points. Try to use thin lines. And these points appear to be in straight line. So this is how we plot a graph for t square and x, where t square is on y-axis and x is on x-axis. So we have a next part in which state whether the graph line shows that t square is proportional to x. From this graph, look, whenever, remember, two quantities are directly proportional, what should be the shape of the graph? Number one, it should be a straight line, and number two, it should pass through the origin. When two quantities are directly proportional, one increase, the other is also increasing. But from graph, how you can determine there should be a straight line which is passing through origin. So if t square and x are directly proportional, there should be a straight line which is starting from 0, 0. So the question is, state whether the graph line show t square and x are proportional, or t square is directly proportional to x. So in a statement, we will say no, they are not directly proportional. And the reason is that the straight line is not passing through origin. There should be a straight line. So it is a straight line, but that straight line is not passing through origin. That's why we say they are not directly proportional. The next part, explain why timing 10 oscillation give more accurate result than for one oscillation. So what is the advantage of recording a time for 10 oscillation? So it reduces the uncertainty. The main thing is it reduces the percentage uncertainty in the value and reduce the timing error as well. So you can mention why timing 10 oscillation give more accurate result, because it reduces the percentage. As you are recording a longer interval or time period, you will have less percentage error or percentage uncertainty or error. So that's the main reason. Like if we are recording a time for one oscillation, it's difficult to record like 1.16 seconds or 1.15 seconds rather than record 16 seconds. That's why we prefer to record time for 20 oscillation, 10 oscillation, instead of recording time for only one oscillation.